Welcome everybody to Onlinestudy4u. In this video, we are going to discuss about stacks and queues and the basic operations about these two data structures. We will not go for specifically the coding part, but we will look at the theoretical part of it. At the end of this video, we have an amazing announcement for you guys about something that can help you to get better placements and get better training. So please watch this video until the end in order to know what is the surprise that we have for you. So now let's get started with our lesson. So the first thing that we're going to talk about today is stacks. So what is stacks? So if you're familiar slightly with the English language, that is stack. So what does this word stack mean? So the word stack means something that is bundled up. Let us say I have 10 subjects in my college or university and I maintain 10 different books for different subjects. So what happens when I keep one book on top of the other? It is a stack of 10 books. Okay. So now imagine that these 10 books are placed on a table. This table looks horrible, but what can I do? I'm so bad at drawing. Okay, so this is on a table, and now if you want to remove a book, which one are you going to remove? So you're going to remove the book that was placed on the top first, right? And then you're going to remove this book, that is the second top one. So you're going to do the same thing. So if you look at the pattern of this, so the last element that was to be placed, that is the last element that came in, was the first element to go out. That is why the stack is called as a LIFO data structure. Another example that you can take in order to explain stacks is the CD holder. So previously we used to use a lot of CDs and DVDs in order to play media content in the computer. So now we use pen drives and flash drives, etc. But in order to play CDs, we had something devices like this. So I used to place my CD here, and on top of this CD, another CD used to come, and another CD, and so on. So now if I wanted to remove the bottommost CD, I cannot do that directly. So I have to remove the topmost CD first, and then I have to go for the next top one. So this is a LIFO data structure, and that appropriately describes stacks. So in memory or in computer memory, stack is a data structure in which you will have array representation for stacks. If you study that in depth, you'll understand. So there will be a variable called top that will point to the top of the stack, just like the topmost CD, topmost book that we have in here. We will have a variable top that will point to the topmost element in the stack, and we keep on adding and removing elements in here. So stack has a lot of different functions that we can have here. So the first function that we can have is that push. So what is push? Is that push is adding a new element to the stack, right? So the stack may be empty, or it may be partially full, or something like that. So push is adding an element to the stack, and the next operation is called pop. So pop is nothing but removing an element from the stack. So this is nothing but adding an element, and this is removing. Okay. So now we have several other operations in stacks as well. So for example, we have our peek operation. What does this peek do? It returns the topmost element. Okay, so if you pop a element from the stack, if you want to know that which element will be popped, you can use this peek operation in order to get that. Okay, you can do operations like get the size of the stacks, and what is the maximum number of elements in the stack, etc. So the general idea about stacks is this, right? So now if you want to go for queues and try to understand what queue is, because it is also one of the basic and important data structure that is used in computer science, and it will be asked in your interviews as well. So you have to be familiar with the terminologies of the queues, and before familiarizing yourself with the terminologies, you should be firm with the theoretical understanding of it. So our next concept for this video will be queues. This is a very simple concept. You must have definitely be standing in a queue either in a grocery shop, in a bus stand, or maybe to get a Geo SIM. Yeah, that was a trend back then. So what is a queue is that there will be a line, okay, and you have to follow that. Let us say this is a grocery shop, okay, and you have gone to buy some grocery for your mom. So now there is a person called A who has come first even before the grocery shop is open. Okay, there are some people who have arrived in the grocery shop, right? Now here you come, okay, this is you. Now what happens when the shop opens, maybe at 10 a.m. okay, when the shop opens, this guy or girl who is the first one to come, so this guy or girl who is the first one to be in will be the first one to get out of the queue. So first in, first out refers to nothing but the queue data structure. So after this element goes out, this person will be the one to go to the shop and get his service. And after this person goes out of the queue, then comes this person, and then comes you. Okay, so if some other person comes to the queue, they get added to the back of the queue and the queue grows. Okay, so this is nothing but exactly the same thing that happens in computer if you use an array representation for a queue. Let us say there will be two variables in here. If you go for a full depth understanding, you will understand that, but here we are looking for an overview. So you will have a pointer or maybe a variable called front to point to the front element, and you will have an element called rear that will point to the rear end of the array. Okay, so by using these two variables and an array, you can implement a queue. So queue also has similar operations just like arrays, stacks. So for example, the first operation that you can study about is enqueue. Enqueue is just like push, which we have studied in stacks, that is adding an element into the queue, and you have dequeue. Dequeue is nothing but removing an element from the queue. And then we have other operations such as size, and maybe what is the front of the queue which we are going to remove. So whenever you are removing, you will be removing from this front end. Whenever you are going to add, you are going to add from the rear end, because so the person who goes out in a queue is normally the person in the front, right? And the person who comes, that is a new person, if the person wants to be added to the queue, that person joins the rear end of the queue, and that is exactly what happens in a queue data structure in computer as well. Now we have been done with our basic explanation of stacks and queues, and you must have a basic idea of what stack and queue is. And